Hello, everyone. Today, I'll walk you through the steps that I took to improve the performance and fit of my regression models. I'll discuss my approach to data processing, feature selection, and hyperparameter tuning, and also validation. To tackle this task, I implemented two regressors, a decision tree model and a light GBM regressor. I used multiple techniques to refine their performance, and I will be comparing their results. The first step is improving model performance. I used exploratory data analysis in which I checked for unique values, duplicates, and missing values in the dataset. This allowed me to clean the data and prepare it for modeling. Next, I also focused optimizing my features by feature selection and preprocessing. I followed these following steps. First, I identified numerical and categorical columns. I also applied median imputation for missing numerical values. I used mode imputation and one-hot encoding for categorical variables. I also use label encoded specific I also label encoded specific categorical features to ensure proper processing. Additionally, I standardized numerical features using robust scalar, which is more resistant to outliers. Finally, I applied recursive feature elimination with random forest regressor to select the top 44 most important features. So after pre-processing the data, I implemented two models. The first one is a decision tree model, which is simple and interpretable. And the second one is a light GBM model, which is an ensemble method that usually generalizes better. To optimize the decision tree model, I used grid search CV to fine-tune hyperparameters such as maximum depth, which controls how deep the tree can go, minimum sample split, which determines when to split the nodes, and minimum sample sleeve, which prevents the model from learning noise. For the light GBM model, I took a more advanced approach. First, I performed grid search CV hyperparameter tuning to optimize key parameters, um, like number of leaves, learning rate, and number of estimators. Then I also checked the feature importance to remove irrelevant features. I also used a correlation heat map to identify and potentially remove redundant features, but I didn't see any redundant features here in the correlation heat map. Um, I also added an interaction term, which is cost per day, which helped capture the relationship between total cost and hospital stay length. Finally, I ran random search CV with fivefold cross validation to further refine the model. So now let's move on to how I assessed the model fit. Firstly, I plotted the learning curves of the model. Oh, and in addition here, well, yeah, I plotted the learning curve of the model, um, to see how they performed as I increased the training data. The decision tree model showed signs of overfitting. And for light GVM learning curve, initially I had a training MSE close to 0, which suggests severe overfitting. So here I increased L1 and L2 regularization to penalize complex models, and I received a better learning curve here because the training MSE is not too low, meaning that the model is learning without overfitting too much, and the validation MSE is steadily decreasing, showing that increasing training data improves performance. And also the training and validation gap is smaller than it used to be. So finally, I compared the mean squared error, which is the MSE scores for both models on the validation set, and the decision tree had a higher MSE, and the light GBM model had a significantly lower MSE, meaning that it is a better model. So, for conclusion, light GBM was the better model because it had a lower validation MSE score, indicating better predictive accuracy. It also has a more balanced learning curve, meaning that it generalized better. And to summarize, the key improvements were feature selection to remove noise, interaction term engineering to enhance the model's predictive power, grid search CV with cross validation for hyperparameter tuning, and future improvements that I can make include trying the XG boost for better predictions, implementing stacking models to combine multiple regressors, uh, and using Bayesian optimization instead of grid search CV for more efficient tuning. Thank you for listening. I hope this gave you insight into improving and evaluating regression models. Let me know if you have any